Welcome to Mixed and Entire Radicals. We know that we can state a fraction in many ways. So our example of 1/4, we know that we can state it as 3/12. We know that we can also state it as 5/20, or 30 1/20, or even 100 over 400. These are all equivalent statements. How do we know these are equivalent? Because we know that we can change a fraction by multiplying by 1. So if I take 1/4, if I multiply by 3 over 3, it'll equal 3 over 12. And that's how I ended up getting there. We can do the same thing with radicals. We can make equivalent statements. So let's look at the square root of 16 times 9. Now that equals the square root of 144. And the square root of 144 is 12. Now what happens if I separate it out? So it's the square root of 16 times the square root of 9. Well, the square root of 16 is 4, and the square root of 9 is 3. That also equals 12. So the square root of 16 times 9 is equivalent to the square root of 16 times the square root of 9. Let's try it with a cubed root. So we have the cubed root of 8 times 27. So that is the same as saying the cubed root of 216, and that equals 6. We know the cubed root of 8 is equal to 2 times the cubed root of 27, which is 3. 2 times 3 is 6. So again, the statement works. The cubed root of 8 times 27 is equivalent to the cube root of 8 times the cube root of 27. This leads us to a rule about multiplication of radicals. So that states that our index of a n times b is the equivalent of the index n is the square root of a times, with the index n, the square root of b. And that is our rule about the multiplication of radicals. Now how do we find 6? There's two actual methods. The first method is using factors. So if we look at the number 24, we know the factors of 24. It's 1 and 24, it's 2 and 12, it is 3 and 8, and it's 4 and 6. We know that. So in order to simplify it, I need to look at a couple of things. What are the perfect squares, or the perfect cubes, or the perfect fourths in the factors? Now, if we take the first example of the square root of 24, I know my index is 2. So that means, out of my factors, I'm going to be looking for a factor in here that is a perfect square. Well, it happens to be 4. So that means I'm going to take 4, the factor of 4, and it's multiplied by 6. I can pull out, I'll be able to pull out my 4, so it's the same as 4, square root of 4 times the square root of 6, which means I can now solve this, which is 2 times the square root of 6. And another way to write this line here is to write it simply as 2 square root of 6. Now let's look at example B. Here we have an index of 3, so that means we are looking for a perfect cubed. So where in here is a number, where in our factors here is a perfect cubed? Well, we see 8. 8 is a perfect cubed. So again, I'm going to have 8, and I know it's times 3, and based on our rules, so we're doing cube root here, I can take the cube root of 8 times the cube root of 3, which equals 2 times the cube root of 3, and I can write it without the little multiplication sign here. It's 2 cubed root of 3. So what we've done is we have actually gone from an entire radical to a mixed radical by finding the factors of our radicand. So this is the radicand. So again, same thing, entire radical to mixed. Using the factors method, go ahead and try a and b, the square root of 147 and the fourth root of 32. Pause the video and come back for the answer. Welcome back. So the answer for the square root of 147, you should have gotten 7 square root 3. And the answer for the fourth root of 32, remember it's the fourth root, not the fifth root, so it makes a difference. The answer is 2 fourth root of 2. Let's look at a second method. This is looking at the prime factorization. So what does that mean? It means we have to break down the numbers by the prime factors. So let's look at 80, the square root of 80 here in example A. Well, I know that it equals 8 times 10, so I'm going to take the square root of 8 times 10, and now I'm going to break down 8 and 10 into the prime factors. So 8 is 2 times 2 times 2, and 10 is 2 times 5. Now what I'm going to do is I'm looking for factors that result in a perfect square. So if I look, I have 2 times 2 and 2 times 2. Those are two perfect squares. So I'm going to isolate those. So that'll equal 2 times 2 times 2 times 2 times 5. Or I can separate them out. Square root of 2 times 2 times the square root of 2 times 2 times the square root of 5. And the square root of 2 times 2 is 2. The square root of 2 times 2 is 2. And then of course the square root of 5, I'm going to keep that. So that means 2 times 2 is 4 times the square root of 5, or I can write it as simply 4 square root of 5. It means the same thing. So again, I have gone from an entire radical to mixed. Let's try another example. The cubed root of 144. So let's break down 44. I know, I'm looking at the cubed root, but I know that 44 is 12 times 12. I know that because it's a perfect square. Now I'm going to break down 12 and 12 into their factors. So I have 2 times 2 times 3 times 2 times 2 times 3. Those are the prime factors. And now if I look at this, because I'm dealing with a cubed here, I need to find a perfect cube in my prime factors. So where is there 3? So what I'm going to do to make it easier for you is I'm going to regroup everything. Now I'm going to put my 2's all together just for you to see. And now I can see I have 1, 2, 3, and that's it. It's just this grouping here. So that means that the cubed root is 2 times 2 times 2 times 2 times 3 times 3. And I can, based on what I've shown you earlier, we can pull out the cubed root of 2 times 2 times 2 and then multiply that by the cubed root of 2 times 3 times 3. So that equals cubed root of 2 times 2 times 2, or the cubed root of 8 is 2 times the cubed root of 2 times 3 times 3, which is the cubed root of 18. So I can rewrite that as 2 cubed root of 18. And again, we've gone from entire to mixed. The same would apply for the fourth root if you're looking for the factors that appear 4 times in the square root sign. So depending on what that index is, that's the perfect power that you're looking for. So you go ahead and try A, the square root of 63, and B, the cubed root of 108. Pause the video, come back and find the answer. Welcome back. You should have gotten for the square root of 63 using our prime factorization method 3 square root of 7. And for B, you should have gotten 3 cubed root of 4.